Okay, let's get started with some more examples. You can go ahead and pause the video, try all of these, and see if you got the hang of it. But we'll go ahead and get started right now. So we've got our function f of x here. We've got the square root of 2 minus x plus 5. Perfect. And we're just going to plug in -3. So we know what to do here. We've got our f of x, and we find the x, and we replace it with parentheses. So f, and we'll do our blank parentheses there. And then have the square root of 2 minus parentheses for that x plus 5. Perfect. And we're plugging in -3. And we plug in -3 there. And then continue going. So we've got 2 minus a -3, which is a +3. 2 plus 3 plus 5. And then we just get the square root of 5 plus 5. Easy enough. Hopefully you got that. Now we can go ahead and go on with evaluating at 2. This one will be just the same. F of 2 equals square root of 2 minus, and we've got those parentheses for that x, where our 2 goes, plus 5. Sweet. Square root of 2 minus 2 is 0, plus 5. Now the square root of 0 is just 0. That's fine. We can do that. 0 plus 5, and we just get 5. Sorry, it's kind of ugly 5. Okay. Now we can practice doing variables. So we've got a b here. Same thing. We've got our parentheses. I kind of skipped this step last time, but make sure you don't skip the step. Minus, and we've got parentheses. Plug in the b into those gaps. This one's not going to simplify much. We've got 2 minus b under that square root plus 5. Now, this next one's kind of interesting. We haven't really dealt with that before. So first, let's go ahead and write our a, or fill in our a. So we'll start with our gaps. Then we've got 2 minus another parenthesis gap plus 5. So we know we plug in our a into those spots, and then our whole function, we're going to make a negative. So this is going to be negative, and because we do that to this side, we do it to this other side. And we have 2 terms here, so both of them receive the negative. Plus, and I'll add the negative to the 5. So plus -5 or -5. So we've got minus the square root of 2 minus a minus 5. Okay, let's go ahead and do this last one. We've got these 2 terms here combined with the plus sign, so that'll be kind of fun. Start by drawing our gaps. We'll make the gaps a little bit bigger because we know our input is a little bit bigger. Plus 5, so a plus h goes into both of those. Perfect. And now we just keep evaluating. So we have 2 minus, and this minus will distribute to both terms, minus a minus h, whoops, plus 5. Okay, those are all fairly straightforward. Let's go ahead and do a few more examples. Okay, so those are fairly straightforward. We've got a couple examples here. I'll draw a line. Don't get confused. Anyway, this one is a little bit different. It's not too hard. We've just got more steps that we need to do. So we have our function g, and written in terms of x, and then we want to evaluate this expression using function g in some different variables. And this is there just to say that, yeah, we know that x cannot equal a. Like, if that's the case, let's evaluate this. X isn't a, because that would give us a 0 in the denominator, and then we end up with no solution. So that's just there for formality reasons, we could say. So we need to evaluate g of x, which we've got already. They gave that to us, which is nice. That's just the basic function. But then we also need to evaluate g where x is equal to a. So we need to plug in a to our function g, and then we solve this whole dealio. So we've got our g of x. Now let's write our function g evaluated at a. So right now I'm just doing my gaps again. Whoops. Our 2 is multiplied by the parentheses, and then these ones are squared because of this x. So we plug in our a into each of those gaps, and then we evaluate evaluate a squared plus 2a is g of a. Okay, so we plugged in a, that was our input. Here's our output. So we have g of x, we have g of a, and then we have, you know, x and a. So we can go ahead and plug those in. So we'll plug in g of x first. We have x squared plus 2x, and then minus, I'm going to put here g of a, which is a squared plus 2a, and I put those in parentheses because we have this minus sign and we want to remember to distribute that. So you could have skipped the parentheses and just added the, you know, multiplied the minus sign to both terms, but I didn't skip that step. And then below we have x minus a. So we can simplify this just a little bit. X squared plus 2x. Now I'm distributing that minus sign, minus a squared minus 2a. We have all over x minus a. Now this is kind of an interesting point to be at because there's no obvious term that we can factor out. We want to see if we can find any terms, or find if we can get an x minus a to cancel with this bottom, if it's possible. We have lots of x's and a's at the top, so we could probably change it a little bit and be able to cancel out that x minus a. So let's go ahead and try that. So we've got an x squared plus a 2x, and they both have an x in common, and if we were to pull out that x, you know, it would be x times x plus 2. So it doesn't really work here, and so what we can do, it's a little less obvious, is we're going to rearrange this real quick, and we'll have x squared minus a squared plus 2x minus 2a. So now we have our 2's next to each other, and this is all over x minus a. We have a 2x minus 2a, and we have an x minus a here. So maybe we could do something here where we can cancel those. So we have so we have an x squared minus a squared, which is the difference of squares, I believe it's called. So we can break these up, and we can also break these up too, because they've got a 2 in common, and we could pull the 2 out. So let me show you what I mean. So we've got x squared plus a squared. Well, a difference of squares, that means we can get an x plus a times an x minus a. And I think these are called conjugates or something like that, where you have the same terms in each of the parentheses, but you have a plus sign and a minus sign. And so what this does is when you FOIL these or multiply them together, the middle terms cancel out because you have a plus ax and a minus ax. And so you end up with x squared minus a squared. So we're able to, that's a pattern that you'll want to be familiar with and recognize, because when we multiply it through, we get x squared plus ax, and then we have minus ax minus a squared. So these cancel, and then we're left with x squared minus a squared. So that's where that came from. Anyway, so we have these multiplied together, plus, then we have 2x minus 2a. So let's factor out that 2, and we're left with x minus a, all over x minus a. Well, sweet! We've got an x minus a here, an x minus a here, and 1 in the denominator. So because we have this term and this term, they're added together, and they have a common factor, we can divide it out with the denominator. So we divide all these out, and we're left with x plus a, and then we've got this plus here, 2. And that is our final answer. So kind of a little hidden, kind of a little bit of a trick there, but you can always rearrange terms on the top and kind of factor out from certain terms like we did here. As long as you're not breaking, you know, any algebra rules, you can do that and manipulate it so you're able to cancel out with the denominator. Doesn't always work, but this time it did, and it's kind of cool when it does. Now this next one, kind of going back to the basics here, we'll just plug in 5 for x for this function. So we've got f with some gaps, make another gap squared, minus 3 times another gap, plug in 5, this one's nice and easy. 5 squared is 25, minus 3 times 5 is 15, we're left with 10. Plugged in 5, we got 10, our input and our output's function. Woo! Easy enough. Well, what about if we're given what f of x is. Okay, so this is a little bit different. We're not plugging in anything for x, we're trying to figure out what x is. So if f of x equals 4, then we're going to replace 4 with this, or we're going to replace f of x with 4. So 4 is equal to x squared minus 3x. Okay, well, cool. When it comes to these polynomials, or we've got an x squared, let's get all the terms on the right side. So we're only left with 0, and that'll make it a lot easier to solve for. So going to subtract 4 over, and we have 0 equals x squared minus 3x minus 4. And now we're going to factor this. So how I like to do it is I use these signs here to kind of help me figure out what my signs will be here. Everybody has a different method of doing this. I hope this one makes sense. I've seen some interesting ways. This is the one that's always worked for me and made sense. So this second sign here tells you whether these signs here are going to be the same or opposite. So if this is a plus sign, these signs are going to be the same. And if it's a minus sign, these signs are going to be opposite. So in this case, the sign is a minus sign, so we're going to have a plus sign and a minus sign, one or the other. They're going to be opposite though. Okay, so we know that they're opposites, and then that's where we use this first sign to tell us what the first sign is going to be. So we know they're going to be opposites, and the first sign is going to be a minus sign. Minus and a plus, like that. So now we use the numbers to figure out what these numbers are going to be. You want these two terms to multiply to get 4 and add or subtract to get 3. And the add or subtract comes from these signs. So anyway, 4, we have 1 times 4 are its factors, as well as 2 times 2. So 2 times 2, those multiply to get 4. If you add them or subtract them, you're not going to get 3, so those aren't it. 1 times 4 gives you 4, and you can subtract these, so 4 minus 1 will give you 3, or 1 minus 4 will give you negative 3. So these are what we're looking for. And then we always put the biggest factor first. And we put the small one second. So there we go. If we multiply this out, we get x squared minus 4x plus x minus 4, like that. And then you negative 4x plus x minus 3x minus 4, which is what we started with. So great, we have our two terms. It's a little messy. I'll rewrite this down below. So we have 0 equals, and we rewrote this broken up into these two factors. So we have x minus 4 and x plus 1. The cool thing with doing it this way is anything times 0 is 0, and we know that. So either this term can equal 0 or this term can equal 0, and we'll get our final answer to be 0. So if this one's equal to 0 and this one is equal to 100, it doesn't matter really what this is equal to, we're always going to get 0, and vice versa. So how we can figure this out is we set this equal to 0 and we set this equal to 0, and we'll figure out our 2x values. So x minus 4 equal to 0, x plus 1 equals 0. And then we just add 4 over, so we get x equals 4. We're running out of room here. And then subtract 1 over, we get x equals negative 1. So these are our two answers. And we got two answers that might be alarming to you, but this is still a function. It's okay that we got that because we have these are our inputs, and the inputs can have the same output. It's just that our input can't have two outputs. So we have two inputs here, and we got one output. So this is a function. It's just not a one-to-one function because these inputs don't have a unique output. They each don't have their own unique output. They share the same output. So it's a function, but not a one-to-one function. Last, we've got some graphs here, and we're just going to see if they are a function or not. So if you saw the vertical line test video, you know that I like to use a scanner, and I was using the ruler before, but this time we're going to use our pencil. So we're going to take our pencil, and this is our vertical line, and we're going to drag it across, and everywhere that our pencil crosses this line, we only want 1 point to cross. We can also draw lines from the graph to the x-axis like this. And as long as there's only one output, not 2 or more, like that, all of these, then it's a function. So that one's good. Now this one, we drag our pencil across and it goes beep, 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 beep. Not a function because our lines, for this input here, we have 2 outputs here. So no good. What about this one? We test. Those are all 1 output, 1 output, 1 output. Pretend I drew this poorly, but this line is supposed to get infinitely close to this line. So it's not actually vertical, it's going at an angle. Anyway, same thing here. It's okay that we've got a gap. That's just not part of the domain, which is coming up in this next video. We'll talk about the domain a little bit more. But where there is a line, where the graph, or where it is graphed, we only have 1 output for every input. So it's good. This one, we've got a sine wave. Drag our pencil across, or draw your lines, and only 1 output for every input. So it's good. This one's a piecewise function, which we haven't really talked about yet, but they're coming. And we're going to drag our line across, and we go beep, 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 beep. It's not going to work because we have 2 outputs for this 1 input here. 2 outputs for that 1 input. So no good. So those are just a few extra examples. If you have any questions or have more examples you want me to cover, totally comment, let me know. And let me know what you think of this video, what you think of this style of video. I'm just kind of messing around, testing different types. So anyway, thanks for watching.